Dr. Joyashil is working as professor in the Department of Computer Science and Engineering at the Indian Institute of Engineering, Science and Technology, Shibpur. She obtained her Bachelor of Engineering degree in Electronics and Telecommunication Engineering in the year 1984 and ME Tele in 1986 and PhD in Computer Science with specialization in Artificial Intelligence and Soft Computing in 1996. The primary research interests of Dr. Joya Shil are in the image processing and computer vision, machine learning, bioinformatics, etc. She was awarded the Corps of Electrical and Mechanical Engineers Prize 1989 to 90 by Institute of Engineers. For Best Journal Paper, she received postdoc fellowship in Nanyang Technological University, Singapore during 2002-2003. Dr. Sheel also visited University of Technology, Wrocław, Poland as senior scientist by INSA under bilateral exchange program in 2012. Her talk is entitled Deep Learning for Text Analysis. And a very brief abstract on his talk to introduce with is the process of collecting, the talk will be on the process of collecting information and finding meaningful insights from unstructured and structured text is known as text analytics, also known as text mining or text data mining. It is always a major challenge for data scientists and researchers to make machines automatically understand text data. Machine understanding of text data reduces the dependencies on humans on many applications, including removing language barrier through translation, product recommendation using sentiment analysis, security, social media analysis, and many others. The association between words in a sentence which has a large vocabulary is a complex task for feature engineering based machine learning models or statistical models. However, deep learning based feature learning methods thrive in this text analytics domain with the availability of a large corpus of text. The sophisticated and sequence based deep learning architectures like RNN and its variants improves the performance of many text analysis like NER, POS, NMTL, neural machine translation, word correction, etc. Other deep learning components like word embedding, transfer learning make it easy to train and process text data. For training and evaluation of performance, various matrices and evaluation frameworks like GLU, BLU, etc. are currently available. Building a language model is key to solving many text applications, which is possible with LSTM, transformer network based deep learning architecture. So with this, I hand over the session to Joyashil Madam. Madam.
Okay, thank you for a nice introduction. So I directly go to the topic, deep learning for text analysis. While I discuss the topic or present the slides, I presume that the audience must obviously know the deep learning. Okay, what is deep learning? Because deep learning is now a buzzword. Deep learning can be used for image processing. Deep learning can be used for text analysis. So deep learning for text analysis. Deep learning for text analysis. I assume that you have idea about recurrent neural network, that is a deep learning model, and with CNN also, convolution neural network. Because this part I have not discussed in very detail, because I think that this is very preliminary, and if I start discussion on this, then the topic will be purely on, that tutorial type of lecture. So instead of that, wherever I think it is required, I take some slides for discussion, and somewhere mostly I concentrate on application of deep learning for different text analysis. And probably this is not with the topic of healthcare, but it could be used in healthcare, because text analysis is also required in healthcare, like seeing some image, we can give some caption of the image of a tumor. Radiologists basically do this, but not using the deep learning method. But now it could be for the advanced technology, you can use it. Okay? So in that sense, it is relevant to the whatever is faculty development program or workshop. Okay, come to the point, deep learning for text analysis. If I start the journey of text analysis, okay, first of all, the content is like this: introduction, neural network for text analysis. Directly I go to the neural network for text analysis, then deep learning for text analysis. These are also deep learning because RNN is there, LSTM is there. And here components of deep learning in text analysis, quite advanced topic: word embedding, transfer learning, training component, then case study on name entity recognition, then evaluation metrics for text analytics, which model will be better for that, what kind of evaluation metrics do we use, and some advanced topic of transfer modeling as well as the attention-based modeling. So as the journey of text analysis is, of course, we need some intelligence, because for human being, if I read a paper or if we listen some news, for us to capture the context of that topic or context of the sentence from the newspaper is not very difficult task. But for doing it using a machine, you need some intelligence. Okay, so basically that human intelligence is incorporated to understanding text in one of the, which is the basic task for machine intelligence. So here, how human try to understand the sentence or text, that we try to incorporate into machine through some intelligence. The availability of large volume of annotated and unannotated complex data set is huge now in the era of internet or social media. We have many text. So whether processing or analyzing it, we can extract meaningful knowledge. That is our motivation. So annotated text, you know, that sentiment classification data set, where mainly the class level is available, okay, or machine translation data set, some data set for which maybe one language it is written, we can convert it into another language. So these are the annotated text, because from the dictionary of different language, we can just translate one word in one particular language to English or any other language, because these are annotated texts, or dictionary is available. But there is also unannotated text, which actually the main challenge of text analysis, that is Wikipedia articles. Okay, those for articles, there is no such task level is given, or there is a mixture of articles. It is not written in a structured form. Facebook, not even always structured. Social media conversation, there may be multiple language for conversation. Some Hindi, some English, maybe some native language is used, because these are all informal communication. So these are unannotated and unstructured. So availability of huge amount of text, whether annotated or unannotated. Sorry, there is a lot of noise coming. Please mute your microphones.
Dear participants, please don't unmute yourself until and unless it is required. Ma'am, please.
So it is that for that availability of this huge amount of text data set, we go for analyze it to extract knowledge using machine intelligence. But initially there was no deep learning, but people are using text analysis for capturing knowledge, and those methods are called feature engineering method, where instead of giving the whole sentence, we extract the feature by our own. So it is the feature engineering is human perception dependent. So it depends on human perception. There are different feature engineering methods, say bag of word, TF-IDF, term frequency, inverse document frequency, n-gram model. These are all feature engineering approach. That means from the text we develop the feature. I mean, through program we develop it, but somehow we understand that this method is good, this method for feature extraction is good, and then we apply it. But if it is not good, then your model performance is not is not acceptable. So again, you have to change the approach. Maybe you have used bag of words. Now it seems to you that TF-IDF model is better. So it is expensive and time consuming. So feature engineering approach previously used, and based on that text analysis also people were doing, but there are some drawback. Like bag of words is that convert each word into a string of 0 and 1 binary. But here the order of the sentence is not maintained. Okay, that means if I say there is no rain today, and if I say that today there is no rain, then the two sentences are same meaning, semantically they are same, but due to the different order of the words, since bag of words not maintain the order, so order of the words, so they are treated as separate features. Okay, so that's the problem of bag of words, where order is important, sequence order is important, bag of word is not suitable. Similarly, probably you know term frequency, inverse document frequency, it only quantitative measurement of the sentence, not context or concept is highlighted here, because based on the frequency or inverse document frequency, we calculate the feature. And n-gram model is order dependent, but n is not any value. Maybe 3 or 4 or 5 is enough for holding the meaning of the sequence. If your sentence length is very large, maybe not even for 10 words, containing 10 words, n-gram model, as it goes away from the center of the centered word of the sentence, the meaning is gradually fading. So n-gram model is also not very useful. Only 2 or 3 gram model where n value is 2 or 3 means the word and its previous word, or word, previous word and successor word are useful for extracting the feature, because we know the order of the words in a sentence has the context. Okay, so they carry some meaningful context, which if you capture, then you'll be able to capture the feature and the model will be better. Performance will be better. But if n is equal to 10 or 8 even, the model will not perform. Performance will not be good. So these are feature engineering approach are previously used. You can check bag of word, what are the limitations of each of these methods. From bag of word, order is not maintained. From that's why TF-IDF model we develop, but TF-IDF model context is not maintained. N-gram model, although context is maintained, but for very few words. Okay, so we'll go for learning of basically neural network based learning. You know, it is supervised learning used for classification using scene data. Scene data means, you know, where class level for a training pattern is given, which is supervised learning. These are mostly used for text classification. If you have some topic and told you that, say, this topic is on based some some phenomena, maybe some disaster, maybe some I mean that entertainment topic, then that means the regarding the text output, it is already provided you, which is for supervised learning. Okay. Then it is another one is unsupervised learning, which is obviously clustering of data, where class levels are not provided, and it is indirect for training large language model, means modeling a particular language, and topic modeling. That means if you have a document or a corpus of documents, then these documents consisting of various topics. Okay, so if you able to find out the words which are related to different topics, maybe a sports related article containing the sports, maybe person concerned, maybe if the person is attached to the political circle, then politics related. So many topics are there in a corpus. So it will able to cluster the words depending on the particular topic. And another one is the reinforcement learning, which is very much new, coming as a new way, reinforcement learning for text analysis, where area of machine learning concerned with how intelligent agents ought to take action. It is agent-based architecture. Agent acts within in the environment and take the feedback to improve its performance or improves its action. It is in the area of text analytics, strategy of long conversation by chatbot. That means different persons can be planned using reinforcement learning approach. Reinforcement learning is something different than supervised and unsupervised. Supervised class level is given, unsupervised class level is not given, but in reinforcement, there is no class level, of course, but there is some feedback which is called reward or penalty. If you are moving to the right direction, if your learning is in the right direction, then you will get feedback as reward, so that you can enhance your, you can follow the same learning path. But if it is in the wrong direction, that means performance supposed to be reduced, so it accepts the penalty and it will check its own action again to get the better result. That is the motivation. And reinforcement learning is not alone can give you better result. Even people are now using deep learning and reinforcement learning, so that with the huge amount of data, deep learning can able to handle huge amount of data. It will able to learn the action to complete a task. Okay, robotics problem, it is very much useful. So now from the supervised and supervised reinforcement, basically the common platform is deep learning. Deep learning is a subset of machine learning. Machine learning is a vast area, maybe any classification, clustering, all these problems are under machine learning. So deep learning is a subset of machine learning. Even deep learning is a subset of neural network learning that uses multi-layered artificial neural network. So I think you know deep learning. What are the main features of deep learning is that they require huge amount of data. Nonlinear transformation as activation function, although nonlinear transformation is required in perceptual neural network, here is also it is required as activation function. Nonlinear transformation is used to learn the feature descriptor from raw data. That is the main difference, that in case of neural network, which is non-deep neural network, where we provide the features, that is feature engineering approach, and here we not extracting the features by our own as a human being. Rather, we supply the raw data, and raw data are learned by the machine, and it exactly extract the features, which are very important features. During feature engineering, we may skip them or they may be hidden. But if you use the deep learning using nonlinear transformation, then it will extract the features or feature maps. It generates the feature map, and as the number of layers are more abstract features are generated. And there is another advantage is that the sharing of weights, like ordinary neural network or perceptron neural network, there is individual connection as separate weight. But here, if you know that CNN or RNN, there is sharing of weights, same weights in particular same type of application. Okay, so for feature map generation, same weight is used. Self feature learning ability and the computation power of new graph processing unit, graphical processing units can be utilized. In deep learning handles huge amount of data. So ordinary CPU is not suitable for processing huge amount of data in the fast speed. So graphical processing unit or GPU now in the market is used for resource or computing purposes. Then different applications are there in text analysis. That is sequence classification or sentiment classification. It is on sentiment analysis. Here you see that classification problem. If there is nothing to like in this movie, if this sentence says the sentiment of a particular movie, then of course it will get the 1 star. Okay. So if the movie representing the satisfaction of the viewer, then of course the number of stars will increase. So this way, maybe this is done manually, but it's automatically you can, anybody can do it, and accordingly can transform the sentiment into the star, number of star, right? Similarly, machine translation, of course, you see if it is a sentence in Russian language, then you can convert it into the English language. So if the vocabulary or the dictionary of each word, each language is available, then you can go from here to here, any language to any language. Okay. So this is the machine translation used. This is called sequence to sequence processing. Text summarization, reading the whole sentences or whole paragraph, we can summarize it. What is the meaning? Maybe there is in the original paragraph, there is so many redundant word, synonymous are there. So you can go for text summarization. Then sequence tagging is also another application, important application, which is called name entity recognition. That means from the sentence, you can understand which is the what particular proper noun you use. That may be the name, that may be the location. Okay, so that may be the season, kind of this. So this is name entity recognition, and parts of speech tagging is also very important, is possible by sequence analysis. And also another important topic, as I told you earlier, topic modeling. If your corpus consisting of many topics, many sentences, so it group the words which are related to a particular topic. Okay, but it's unsupervised learning. So major types of neural network used for text processing is feed-forward neural network, we know, which is called fully connected network, which is perceptron type. Then recurrent neural network and its variant. Recurrent neural network, its variants are LSTM, long short-term memory, because ordinary RNN, or which is called also vanilla RNN, there is some drawback or limitation. For that, people are developing new, which is called long short-term memory or gated recurrent unit. they are initially changed the dynamics of text understanding. This development of these two model changed the dynamics of text understanding a great way. Okay? Before that, CNN is not much useful in text analysis. Convolution neural network is more useful for image analysis, right? So convolution neural network is less used, but when you know the RNN, it is mainly for text analysis. Why? Because RNN can handle sequence data, but CNN cannot handle sequence data. That's why it is more suitable for image processing. And there is also transformer network, which is now present at present current state of the art model for text analysis. Just a minute, I sip some water. Okay. Now you know the simple architecture of neural network. Here is a neuron. We have seen, you can see neuron. The main input is here is the input feature vector x with n dimension. And so this is only one neuron. There may be another neuron and so on. B is the bias. I think you know the bias. W is the weight connected with the input, and this sum of product is coming here, which is nothing but a linear function. And after this linearity, because human brain is not linear, nonlinear, complex pattern understanding, you require nonlinearity. So a nonlinear function is after this linear function or sum of product, there is a nonlinear function which is called activation function. After nonlinearity, nonlinear transformation from here, you'll get the output. This is the simple neuron as people are thinking, but mainly it becomes going to complex, not only single neuron, there may be multiple neuron, there may not be one layer, there may be multiple layer and so on. Different types of nonlinearity, loss function for supervised modeling, these are there. But this is a basic, very simple, fully connected network. So from here we come to the recurrent neural network, where because you know the humans do not start their thinking from scratch. We must have some clue, based on that we'll start our thinking, whether it is anything related to family matters, related to official matter. We start thinking, taking some clue. Okay. So humans do not start their thinking from scratch because thoughts have persistence. Thoughts can persist, and based on that, new thoughts, new findings are coming. So, like that, a traditional neural network, which is a fit for a neural network, we assume that all inputs are independent of each other. That means it's not order dependent. Basically, for neural network perceptron model or any other classifier, it is called inputs are IID. IID means independent, identically distributed pattern. That means it does not depend that whether you will give the first pattern at the first slot and second pattern at the second slot, not like that. Randomly, you can take any pattern and can apply for learning, okay, as input pattern. That's why they are called independently identically distributed. So each of them have same distribution. So order is not important in the traditional neural network, that is perceptron model. But RNNs address this issue because you do not always require some pre and post information. And RNN address this issue with loops in them, which holds the information, allowing information to persist. So basically, the recurrent neural network structure is, here is the input, here is the recurrent neural network model, and you see there is a loop. Okay, so it holds the information, whatever in it, it holds the information. It may send it the output node for prediction, a vector at some time state, but when a new input comes, it also holds the input information in the RNN, which is represented by the hidden layer. Okay, so if you think it is the input layer, input node, input, then hidden layer, then this, and this hidden layer loop exists. That means it holds the information so far you give here multiplied by the weight and so on operation is there, and RNN holds this output, holds this information and pass it to the output. So supervised learning as label data is to be provided. Recurrent neural network is also supervised model. So if you want to go for topic modeling, you have to, for a particular document, the topic, name of the topic must be given. So it is topic modeling approach. So supervised learning as label data is to be provided. Supervised learning, of course, if label data is there, then it is supervised. So recurrent neural network is a type of neural network where the output from previous step are fed as input to the current step. This loop is important. The idea behind RNNs is to make use of sequential information present in the input, output, or in most general in both cases. It must be sequential information. You have to sequence to sequence information is applied both for input, and since supervised in the output, it may also give the sequential information. RNNs accept an input vector X and give an output vector Y. Crucially, this output vector's contents are influenced by the input and just fed in on the entire history of inputs you have fed in the past. So previous sequence are important. In theory, RNNs can make use of information in arbitrarily long sequence, but basically in practice, they are limited to looking back only a few steps. Although theoretically it says that long sequence chain it can able to handle, but practically not due to some reason of the algorithm, training algorithm. So it is limited to looking back only a few steps, means short length sequence it can able to handle. So why it is called RNN? RNNs are called recurrent because they perform the same task for every element of a sequence. So in a sequence consisting of words, for each word, it do the same task. That means it shared the weights, with the output being dependent on the previous computation. RNNs have a memory. Since the hidden layer there is a loop, it holds the previous information. So it seems to be like a memory which capture information about what has been calculated so far. To maintain word order, its characteristics is that bag of words model, there is no order, but it maintains the word order. To share parameters across the sequence, there is sharing of parameters or weights, means dimensionality or handling computational complexity is less, which is not in perceptron neural network, but of course it is in convolution neural network. To keep track of long-term dependency, but again, it is not unlimited. We have to apply it for a particular sequence. Now, how do you send the or feed the input to the neural network or recurrent neural network? It is as a vocabulary of dictionary, a vocabulary or dictionary of words of finite size. So when you are going to analyze the text, you assume that you have the, if it is written in English, you assume that you have the words, dictionary words or vocabulary for English. Okay, that means the sentences using all the words available in the dictionary. One vector representation of for each word that is xi of dimension say 10,000. If you consider a paragraph of several sentences, then you assume that this paragraph consisting of 10,000 vocabulary or words. So you make the dimension of your input is 10,000, but it's very sparse because a sentence consisting of the typical word, and for each word there is a one hot vector called one hot vector of 10,000 dimension. Only one element will be 1, rest will be 0. Okay, that way each word is represented. So 10,000 is the word we consider as the vocabulary, right? So if I say the sky is blue, then maybe there is 10, since there is 10,000 word, and assume that dictionary wise wherever is the sky, the sky is blue, only the first, and in case of the sky, for the only one component of the vector will be 1, rest will be 0. Similarly, sky and is and blue, but may, of course, there is for the different position depending on their appearance in the vocabulary. So it is very sparse, the input. Provide input-output pair, but for each input, output dimension may be different, because if the sentence length is different, then your output dimension also will be different. One layer in the RNN for each word of a sentence. So each hidden layer is for each sentence. If you have a sentence of length 5 consisting of 5 words, then it has 5 hidden layers. Okay. There is many more sentences. Maybe you can apply for each word one hidden layer. So if you take this example, that is, my name is Rajat is the input, and at different time, say time t, you provide the my, this word, because it is a sequence. At the next sequence, t plus 1, it is name, and so on. And it is the unfolded. Basically, it is the loop is there. Okay. After my as the input, there is one weight between input to hidden layer, which is WXH, right? And there is one weight which is through the loop hidden layer, WHH. It is from the previous cycle, and it going to the next, for the next word. So one is input for input to hidden layer, another is hidden to hidden, and another is hidden to output. Okay, so it will go for, it will my, if I give my, it predicts something, and coming here that one to this, so that name has some association with the my, then my name will come here and is, and then it will predict the, if the last word is absent, then it can predict some name. Okay. So xt is the input at time step t, w is the weight between the neuron nodes, and ht minus 1 is the hidden input at time step t. So for each word, at the sequence I will provide, at first time I will provide my, then name, then is, then Rajat. Okay. So the sequence is important. I will not give my, then is, then name, then Rajat like this. So when it is required to predict the next word of a sentence, the previous words are required, and hence there is a need to remember the previous words that you understand. And hidden state has this role, which is the most important feature of RNN is hidden state, which remembers some information about a sequence. That is, the hidden state output at time t is equal to, is a function of time step t, depends on time step t minus 1, which holds the previous state information, and the current input xt, right? So xt is the current state, ht minus 1 is previous state, and xt is the input state. So ht, we apply some nonlinear function tan h. Now since it is a function of ht minus 1, so as you see here that weight, which is the within the hidden layer, so it is WHH multiplied with the previous state hidden information, and the input WXH between input to hidden and the input itself. So this way you will calculate the next state information which is stored, okay, for another word, and the output will be just output between hidden to output layer and this HT, right? So this way ultimately output is computed this, and if it is a multi-class problem, you can, or two-class problem, after that you apply the softmax or sigmoidal function to classify based on the probability what class the sentence belong. If it is sentiment analysis, maybe for a particular sentiment, or if it is that last word, if you want to predict, it will able to predict that. Say I give my name is, so it will predict some sentence. Or if I say hello as a character word recognition, if I give HELL as the sequence, it will predict the O. So the weight matrices are filters that determine how much importance to accord to both the present input and the past hidden state. So it, like other backpropagation learning algorithm, here also we go for backpropagation learning training, and weight matrix holds the importance of each word and store it. So of course, since it is a backpropagation algorithm, you must have some learning, and you understand the loss function is similar to previous computed output and original output, and backpropagation here through time. Each time sequence it will, because it is a function of t. Okay, so t is equal to 1 to capital T means the number of sequence, capital T. So each point in time at time step t, the derivative of the loss with respect to weight is expressed in this way. So of course, same as loss function multiply with diminishing means we try to minimize the loss with respect to what, but here the time step is important, and there is one summation to calculate the total loss function. So it is kind of this, if you give a total sequence, okay, so it will coming forward computation this way, then weight adjustment, and for each case, for each hidden layer, for each word, this is one column, for each word there is this column. So after this, it will calculate the loss for each, because this is supervised, we have also supplied the output, and the total loss is calculated as the sum of the loss for different time step depending on the length of the sequence. Okay, but it has some drawback. Recurrent neural network can able to handle short length sequence. Say, if you have a long sentence like this, I spent 20 long years working for the underprivileged kids in Spain. I then moved to Africa. Now for Africa related, there are a lot of information here. Okay, in between these two lines. And last sentence is, I can speak fluent. There is the gap which you have to predict. So of course, we human being able to understand that a person spent 20 long years in Spain, so can fluently speak in speak Spanish. Okay, but there are a lot of very unimportant or irrelevant sentences in between, which are not useful to predict the Spanish. Okay, the language, right? So how to tackle this? RNN will not able to tackle this because of the long sequence. It forget the previous one, maybe it remembers the Africa related point and forget the previous one which are related to Spain, and not clearly correctly able to predict the language. So to make a proper prediction, the RNN needs to remember this context. Since it does not extract the context, so it must require the context, and to hold the context, you must find out the relevant information, not the all information. To make a proper prediction, RNN needs to remember the context. The relevant information may be separated from the point where it is needed from the relevant data. So up to this, it is relevant for predicting this sentence or this word, but the in between are not relevant, right? So how to tackle this? So that how do we forget this information? Or we can make the difference between important and unimportant information. So the relevant information may be separated, but the reason behind this is the problem of vanishing gradient. If you have so many sentences, so many words, so obviously back to the loss function going to adjust within the words ultimately vanishes if the length of the sequence is very large. This vanishing gradient problem is also common in CNN, even in perceptron neural network, it is also common. Vanishing gradient means when gradient vanishes, that means the nonlinearity vanishes, and at that time there is no way to change the weight to reduce the loss function. Okay. So the effect of weight diminishes for long sequence during backpropagation. Remedy is that use cell state in long short-term memory or gated recurrent unit where RNN is not useful for handling vanishing gradient problem. And there is another also here which is called exploding gradient where maybe the weights are very large, getting increased exponentially because of the long sentence, number of words are more, summation is also more. That's why it may be that gradient is exploded. So that is another problem. Here the remedy is that clip the weights in each repetition. Sometimes we make that forcibly reduce the weight so that it will not increase more, capping the maximum value for the gradient. So if you have any question in between, you may interact with me. So here you see that my is going here, it is loop here. But if I give this way, another name is there, it will again reducing. Okay, so this way, if I give more sentence, ultimately this gradient vanishes. And gradient means nothing but non-linearity. So each time we will reduce the non-linearity because of loss function with respect to weight. Okay, so if gradient vanishes, then no more weight adjustment is possible. So for this problem limitation, we come to the long-term dependency module, which is called long short-term memory. Okay, it is also memory. RNN is memory, it is also memory, but the way it handles the information is different. RNN remembers things for just small duration of time, but once a lot of words are fed in, this information gets lost somewhere. It can only able to hold the information which is very recent, and late information it forgets. In RNN, there is no consideration for important and not so important information. So it must be separate that important information which allow to proceed, but not so important or not so relevant information you block for sequence passing, and this way can able to handle the important information, context or content in long short-term memory network. This is also deep learning model. The core concept of long short-term memory at the cell state, okay, and it has various gates. So cell state performs like memory, it also performs forgetting information, it also performs updating information and output information through various gates. So it's kind of a controlled way to pass the information. The cell state acts as a transport highway that transfers relative information all the way down the sequence of chain. There are variant of LSTMs like gated recurrent unit that utilize the gates in different manner to address the problem of long-term dependency. So this is the structure of LSTM. I assume that you know, but still I give you that some idea. Here you see 3 gates are there. Okay, LSTM, this is the total cell, but here is 3 gate doing some manipulation or processing on the text. One is the forget gate, which forget the less important information. Forget means it will not allow to pass the information. If it allows to, which is important, it will allow to pass, which is unimportant, it does not allow to pass. Then it is the update gate. If information passes, then it update the previous information and holds, right? And then it will output the important and updated information to the at time step t. So it is basically the cell is using as a path of highway, where to block, where to pass, where to update.
না এখন হচ্ছে না practical আছে
Shall I proceed?
Yes, ma'am. Yes, ma'am. Please.
There is some, you please mute yourself.
Yes, ma'am. Yes, ma'am.
CT minus 1 is the cell state at time step t minus 1. Okay, this is the at time step t minus 1. So it is coming from previous sequence. Now sigma and tan h are the activation function. Somewhere sigma is used here, tan h and sigma both are used. B is the bias information, W is the weight between the neuron nodes, XT is the time input at time step t, HT minus 1 is the hidden input at time step t, YT minus 1 is the output at time step t. Okay, so FT is calculated as the forget output, forget get output. It is multiplied with the weight, forward weight, and is a function of hidden state input and bias and multiplied by a nonlinear function. After forget, if it will take, since it is a sigmoid or sigmoidal function, if you want to forget the information, then it produces the output 0. Okay, and if it holds the information, previous information, then the sigmoidal output function, that means based on this computation, sigmoidal will give the 1 output. So 1 output means it allow the information to pass, right? Then it is the update input information is going from here, which is xt and also ht minus 1, depending on the input sigma this and bias. Okay, and if there is any updating of information, since we forget some information, that means we make some information irrelevant, so we stop it, remove it, or if we allow it to pass it, then we add it. Okay, so that's why it is the updated get. And for that, there is another function which is tan h, will produce the c dash t, okay, at time t. And c dash t2, it will produce ct, which is the both ft ct and it c dash t, right? So this way, total output will now get from here, and ht is output into tan h ct, that is coming from here. So here the main difference with the vanilla is that it holds the important information and making the activation function high, it will pass it, and if it say it is not relevant, then maybe it is redundant also, then it blocks it. Okay. This is the function of LSTM, and gated recurrent unit is also same like this. Now using this LSTM, as I assume that you know LSTM, we can also make some application using bidirectional LSTM. That means one forward pass, another backward pass. Here it sometimes we happen we forget some word in a poem or in a song. Okay, so for that, or some text in the book is not very well readable. Okay, so in that case, we will apply a bidirectional LSTM for effectively capturing the information which is missing or which is you're not able to remember. From start of the sequence to end, called the forward pass, it will go send the input and it go for forward pass. From end to, so it will start to remember the words from start to end and from again end to start, right? And in the meantime, where there is they coincide, that is the word it able to find. So from ends to start called the backward pass. So there is forward pass as well as there is backward pass. This forward and backward LSTM together called the bidirectional LSTM. So if any word is missing or not able to remember it, then you go for whatever you have information, continuous info sequence, you apply, go for forward pass, and then from in they do the same thing, go for backward pass. Then neural network for other modeling, which is called sequence to sequence modeling, and it is also called encoder decoder model. This is used for machine translation as well as the text summarization. Machine translation means if you give one word in English or in Bengali, it will transfer, change it, translate it into another language. Okay, depending on the vocabulary wise the input you are providing. So this is called the encoder model, where LSTM is here, two layer of LSTM is there. There is some word embedding is there, how the word is represented, word embedding is there, we discuss about this. Then it is the LSTM layer 1, and it passes two way, going to the next layer as well as in the same layer. Okay, so it encode the information, and this encoded information, that means this English sentence is represented some binary form. Okay, so it will go to the decoder model, where the first from the encoder information, and from SOS means start of sentence sequence, usually randomly you have to give. So it is the embedding is here, then layer 1, layer 2, fully connected layer. Then it will generate the one hot vector, and for that the word will be Mera. Mera, when it is coming, then it will use for decoding the next one, and the same way it will able to decode Mera Naam Rajut you have given here. It will complete it as a Mera Naam Rajut hai. Okay, so this is a machine translation. You'll be more learn if you write the code and learn the program, okay, in the TensorFlow or PyChart. But from here you can get some idea that how LSTM is used for different application, different purposes. So mainly used for neural machine translation, then also used for text summarization. If you read a text in the newspaper, a paragraph of a news, then we can obviously find out that what is the summarized form, because there are so many redundant words, sentences, irrelevant words. So that's why it is also used for encoder-decoder model, or sequence-to-sequence model is used for that. It has another application of chat model. That means giving here how are you as the end of shows the end of language. Here, how are you? It is the encoder model will encode it, some information as W. Okay. Here is also, you see there is parallel encoding is there, but here only single from many to one encoded information is there, and that is going to the decoder model where it gives the reply, I am fine. Okay, it is the end of line. So this is the sequence to sequence modeling is used for different purposes. Now another important topic, I just touch upon the different important topics on the text analysis using deep learning. If you have any question, you may ask. Do you have any question? Okay. So
Yes.
it
Yes,
is
madam. So
word embedding. That means how word is represented so that it can capture the context of other words, its surrounding words. That's why it is word embedding. One word vector is very sparse, and only individual word it represents, meaning is represents. But if you're able to find the similarity between words which are contextually similar, then it will be helpful, which is the task of word embedding. So what to make, who have already worked on LSTM, they know. So that is one embedding method. A word embedding is a learned representation for text, where words that have the same meaning have a similar representation using a vector corresponding to each word. So like if it is the all the fruits are there, so they have they represent each column represents something. Okay, maybe color, maybe taste, and so on. So this is represented in this way. Similarly, banana, it is also the similar to here. Maybe with the apple and banana, the color difference is too much, yellow, green, or red. So it has the value is different. Okay, so this way, these are the animals. These are the Google Home, other contextual information too. So this way, each word is embedded as a vector. Okay. So it is capable of capturing context of a word in a document semantically as well as syntactically. If they are similar, they find the relation with other words. Okay, that is the advantage of word embedding. So word embedding has also significance. It reduces the dimensionality, because the similar words are very, if you take it and as a single word and only keep the similarity measurement, then it is, instead of storing all the words, similarity value will give you the idea that what is the context. One of the benefits of using dense and low dimensional vector is computationally effective. Okay, so instead of parse, it is better if you use the dense vector and low dimensional, because one hot vector is dimension is huge as well as it is very sparse. So this kind of representation is good. The majority of neural network toolkits do not play well with very high dimensional sparse vectors. That means an LKT toolkit, if you use, you can understand that it will not able to handle sparse vector and high dimensional vector. Training word embedding can capture association between various words without having a label data, as words occurring frequently together will affect the embedding vectors while training. Okay. Training can capture association, that means relation between various words or context. That is also helpful. So if you see the word embedding phenomena, the distance between the similar words are minimum after dimensionality reduction. So cat and kitten, if you say that they are very close to each other compared to the dog. Okay. Similarly, houses is also in separate position. So they are very similar. Similarly, man, woman, okay, king, queen, these differences has been used. So if you have different word, you are go to word embedding, it will be say from 7 dimension to it will go to 2 dimension. From 7 dimension, it will also go to 2 dimension by measuring the similarity. Okay. So that is one advantage for word embedding. Process and embedding layer is used in TensorFlow and PyTorch for word embedding, that is learned jointly with a neural network model trained on natural language processing tasks such as language modeling. The size of the vector space is usually 50, 100 or 300 dimension has been reduced a great way. Advantage is that word embedding from large language model can be used to increase the efficiency of many tasks. Embedding can be shared between different tasks like name entity recognition, parts of speech tagging, make transfer learning strategy possible for text analytics to large extent. So transfer learning is another important part where in many real world applications, who know the CNN, they also know that some pretend network is used for fine tuning the same type of task. So it is beneficial to use the already learned information. It reduces the training time complexity. At the same time, may increase the effectiveness of newly trained model. And here the loss function is used, the log loss function for training text-related problem, mostly categorical cross-entropy logs function is used, where y is a word token and it is the computed output. So it is negative. So we always try to reduce the loss and use the backpropagation algorithm for that. Another model is called conditional random field. It was there before deep learning also, but CRF now newly used with the deep learning. Conditional random field, that is like probability. If you have some cause effect, then you have to find out what is the cause. Okay. Tags the label of a sentence jointly for each word. That means here if you know one word, then what could be the next word that can be predicted. They use contextual information from previous levels, thus increasing the amount of information the model has to make a good prediction, useful for sequence tagging, that means name entity recognition, phrase tagging, they have been used. So this is some example case study. The most important basic sequence tagging task which is used for using the CRF is the named entity recognition. Say if you have the word steel in Asia, comma, President Clinton, the name entity recognition will not able to find out this is the name. They will make it others group. Similarly in, but Asia can be used as sentence location. This is the location tagging. Here it is also others. President is also not able to find out. It is also others. But Clinton will be sentenced as person, okay, which is the name entity recognition. Similarly, phrase tagging is also there. It is the adverb, okay. Then it is in is the preposition. Similarly, noun on proper noun. It is just comma is for stop word. So this way, phrase entity recognition, name entity recognition, phrase tagging, these are also used. Then name entity recognition actually labels each atomic word present in a sentence into named entity tags. Tags like person, organization, location, okay, maybe some season, etc. remains well-recognized challenge now in the natural language processing community. These are all very important state-of-the-art models are available. So name entity recognition able to this only can able to recognize that location and Clinton, which are actually the name. There is application of NER serve as a background to application like entity conference resolution. Conference entity record resolution are becoming more sophisticated. Entity core inference, it is actually written wrongly. Classifying content for new providers, efficient search algorithm, powering current content recommendation, customer support, accessing research articles using name entity. If you want to search some topic name, okay, or some instrument name, it will able to find out the topics. This data set shared task, it is some, these all data set are prepared from some quiz in the conference. So there's a Colonel 2003 shared task is this way. They have used sentence and developed sentence, total sentence among them. 10 use this, test this, and during the development is 3466 is used for development. Token of words this much, and training is this much. Named entity type may be person, location, organization, and miscellaneous. Made using Reuters corpora data, NIST or MNIST to provide distribution of RCB1, and any future Reuters reporters is also there. And these are all very state-of-the-art model now people are using. Just it's not able to discuss in detail the architecture, only just give an example wise I'm able to give you an idea. So word embedding which are non-trainable, say still, in, then word vector Asia, okay, which is word and vector because this is location wise. These are President Clinton signed, okay. So word embedding is possible to make it. For each one, this is for still, in, all the word embedding is possible. Here it is one is shown here. So this is going to word level LSTM. So they process, so it is everywhere LSTM means it is the hidden layer loop is there. Then it goes to the next layer, another LSTM layer. And finally, you may add additional layer to set of fully connected layers also. Finally, it will be able to recognize that this is the sentence for location, sentence for person. And conditional random field is used because there may be some redundant tagging is there. So it will handle it just computational purposes. It will merge all the tags which are very similar. Maybe person-wise, many persons are there, are separately tagged. Same person has separately tagged, so it will merge them as a single tag. Okay. So the sequence of words in a sentence, word embedding, bidirectional LSTM, fully connected layer for output, and conditional random field layer. For softmax probability for tags of each word you can use for finding the output. Then character embedding, previously you see the word embedding. You can go to the file level, maybe the character embedding, where character embedding using each of this Asia will go for this LSTM. And after character embedding, it goes for word embedding and so on. In that case, it will be that more appropriate named entity recognition is possible because all this location or say name are proper noun. So in that case, it will be helpful. If we start from the character level, it will be fine-tuned it. Similarly, stack bidirectional LSTM in many advanced models, more than one layer of neural network is used. of course. Bidirectional LSTM are also stacked one upon another. Like CNN, LSTM may be also stacked LSTM. And one approach is that each forward pass and backward hidden state is transferred as input for the next layer. So all the stack operation, same type of operation is performed and then proceed for send it to the next layer. Another way is to concatenate the forward and backward layer and then pass it to the next layer. This is stack layer is used for erroneous word correction. If you have given some word with the wrong spelling, then it will be able to find out the position where there is a mistake, and next you can able to rectify it. So if it is that this one example for some Bengali word, here it is there, and going for character level LSTM, then word level LSTM, and if it goes for merging these two, the output character as well as the word, then it will go to the fully connected, and if there is any mistake in the character, say here it is the mistake, here it will able to find out. Okay, so an example of using stack bidirectional LSTM to correct an erroneously written Bengali word to a most appropriate in vocabulary word close to the vocabulary word, giving character as input through character embedding. Another topic, that is the performance metric for each of this model. So you know the F1 score, accuracy, correlation coefficient, and the standard method for considering the model performance. Other than this, sequence evaluation is a Python framework for sentence labeling evaluation. You can use this. Other than this, there are some for text machine translation, text summarization, BLEU, bilingual evaluation and study. It is another metric. It's an algorithm basically to find out that whether machine translation is close to the human translation. Then Meteor is an automatic metric for machine translation evaluation that is based on a generalized concept of unigram matching between the machine-produced translation and human-produced reference translation. And GLEU is also another metric which is variant of BLEU. BLEU may be 2-gram model, here n-gram overlap model is used. Okay, similarly, other framework is there. Indic Blue, that is a variant of Blue. Comet is there for cross-lingual optimized metric. Actually, these are all research topics. Every day they are coming with some conference quiz and conference competition. Rather, from there they are generating different data set and different metric, and these are becoming benchmark which you may use. Okay. So RUG is also another one, SQUAD is another one. So, and the state of the art model, which is very advanced, that is the attention-based LSTM for sentence level code mix sentence correction. Say in the social media, generally people are writing in Roman script some Bengali word or Hindi word. So this way they are maybe mixed. Okay. Or it is not the complete word, say I want is written WNT. So attention model, it will give the more attention of this kind of word and find out the correct one. It's not that every word giving the equal attention. That's why it is called attention based model, which are actually not complete or containing mixed language. It gives the attention and find out that correct dictionary word. So this model, how many layer you will take, what will be the hyperparameter you will decide. These are very much experimental oriented. Idea is clear, but how do you set the hyperparameter? Very experimental oriented. Similarly, transformer model is also like this. is used for one sentence, say, Amar chai international khabor, please. So it will transform. So it is a code mix. Two different language code are used, but written in Roman script. So it will be transformed into a English sentence, okay, or the sentence you want, maybe from English to go to Bengali and written into the Bengali script. So these are all very much very new research is coming up, and state of the art work is also there. If you are interested, you can go for your research in this line. Okay, so I think it's end my presentation. If you have any question, you may ask.
Thank you, madam, for your illuminating session. Many of the important parameters and aspects on which our FDP is focused for rest 4 days have been well explained, and I think participants have also felt a point of interest. So now for few questions we can take, or any interaction one by one. Obviously, do not unmute yourselves at a time. So if you have any question to ask on this session only, not any other question. So the session is open now.
Dear participants, you may unmute yourself and ask the question if you want to ask.
Please, very quick question. I have meeting after 5 minutes.
Yes, ma'am. Also, it is almost 1.5 hour. Your session was. So otherwise, ma'am, you can please share your email ID, or if you permit, we can share, so that if participants have any query.
My email ID is
or,
with you, so you can
yes,
also
I can share.
with them.
Yes, no problem, madam.
Okay.
So I will share, and if the students have anything to ask or anything to know further, so they can communicate you.
Okay, thank you.
With this, I express heartfelt and sincere thanks on behalf of the organizing committee of Department of Computer Science and Engineering, Maulana Abul Kalam Azad, University of Technology, West Bengal, to Professor Joyashil Madam for her illuminating talk on this session 3, day 1, FDP on application of AI, machine learning and deep learning in smart healthcare. Madam, we are thankful to you, and we hope to have you in future events as well of our department and of our university.
Thank you. Thank you to the organizer for giving me the chance, because it has been rescheduled several times because of my engagement. Thank you for bearing this. Okay.
Yeah, no, ma'am, that is not an issue, because in spite of your busy schedule and very important assignments, you have make it out for being with us. So thank you once again, ma'am. And future communications will be done with you on behalf of the organizing committee. And ma'am, as part of the ICT ATAL FDP mandate, we need to share some study material with the participants. So with your convenience, if you share some material, then that will be shared with the students.
Material means PPT is not?
PPT, yeah, no problem.
Okay.
Anything.
So I will
anything.
edit it and send it.
Okay, ma'am. Okay, ma'am.